Hello everyone, welcome to New Alger Commerce College MOOC. I am Dr. Stuti Dholakia. I am working as the Associate Professor at New Alger Commerce College. Today we are going to see the topics of Statistics Semester 3, Unit 4, Negative Binomial and Geometric Distribution. Today we are going to learn the second method of negative binomial distribution examples. Let's just recall the earlier formulas. The probability mass function of negative binomial distribution is P of x, that is equal to n plus x minus 1 C n minus 1 P raised to n Q raised to x. The parameters of the distributions are n and p or n and q. Mean of this distribution is nq upon p. Variance of this distribution is nq upon p square. That can be considered as mean upon p. And standard deviation will be square root of variance. Now let's just recall that Pascal's triangle. This we have seen in earlier that how to calculate this Pascal's triangle. Now suppose I want to go for 6 CR values. That means I have to consider sixth one. Then start counting from number 1. That is 6C0 is 1. 6C1 that will be 6. 6C2 that will be 15. 6C3 that is 20. 6C4 and so on. Now let's consider the blank steps of this for examples. Total trials we are going to assume it to be equal to n plus x. Number of successful trials that is equal to n. So number of failures will be x. P will be considered as the probability of success. Q will be considered as the probability of failure, that will be 1 minus p. And P of x, the formula is n plus x minus 1 C n minus 1 P raised to n Q raised to x. Now let's see the example of the second method. The question is, in the box containing mangoes, 80% of the mangoes are of bad quality. A person needs 5 good mangoes. Find the probability that in the ninth trial, he will have fifth good mango. Also find mean and variance of the number of failures before the successful trial. Now here if you can just check out the question, the probability of a bad mango is given and we need good mangoes. That means there are two opposite situations. So in earlier method, probability of success was given, but now here probability of failure is given. If you just check out the question, total trials will be 9, successful trials will be 5 and probability of failure will be now 80%. Let's just write down these numbers. So n plus x is equal to 9, n that will be 5, so x is 4. And now q is 80%, that means it is 80 upon 100, that is 0.8. So p value will be 1 minus q, that is 0.2. Now let's use the formula of negative binomial distribution, that is n plus x minus 1 C n minus 1 P raised to n Q raised to x. Now let's just substitute all the earlier numbers. So n plus x minus 1 that will be 9 minus 1, that is 8. N minus 1 that will be 5 minus 1, that is 4. So the value will be 8C4, 0.2 raised to 5, 0.8 raised to 4. Now you can calculate 8C4 either by NCR formula or let's just go for Pascal's triangle. Here we have to check out the 8th line. Start from 0, 1 and so on. So 8C4 value will be 70. Let's substitute this in the formula of probability mass function of negative binomial distribution. So P of x value will be 70. 0.2 raised to 5 that is 0.00032 and 0.8 raised to 4 that is 0.4096. So the final answer will be 0.0091. Now let's find out mean. that is NQ upon P, that is 5 into 0.8 upon 0.2, that will be 20. Similarly, variance will be NQ upon P square or mean upon P. So that will be finally 100. This is how we can solve this type of example. Let's see another example of the same type. Now the question is, the probability that a potato is stale in a lot of potatoes is 0.2. A person requires 4 good potatoes. Find the probability of getting 4th good potato when he inspect 6th potato. Here also you can see that we need good potatoes. The probability that is given as the probability of a stale potato. That means these are two opposite things. So rather than p value, we have to assume that number in q value. Total inspected potatoes are 6. So n plus x is 6. We need 4 good potatoes. That means n is 4. And q value will be equal to 0.2. Let's summarize these values. So n plus x is 6. N is 4. So x is 2. Q 0.2. So p value will be 0.8. Let's substitute in the probability mass function of negative binomial distribution. So that will give us 5C3, 0.8 raised to 4, 0.2 raised to 2. Now let's use that Pascal's triangle to calculate 5C3. Here you can see that value 5C3 is 10. So substitute this number. So we will get the final answer as 0.0164. Now let's check out the last example of this method. The probability that a bulb is defective is 0.3. A person requires 7 good bulbs. Find the probability of getting 7th good bulb when he inspects 11th bulb. So now I hope you can write it down all the numbers. Let's just go further. Let's substitute the values. N plus x is 11. N is 7, so x is 4. Now once again q value will be 0.3, so p value will be 0.7. Substitute these numbers in the formula of negative binomial distribution. So we will get 10C6, 0.7 raised to 7, 0.3 raised to 4. Let's find this value using Pascal's triangle. So 10C6 value will be 210. Let's substitute this number in the formula. So p of x value will be 210 into 0.0823 into 0.0081. So final answer will be 0.13999. I hope now this method is clear to all of you. Thank you so much.